This is the first of our lessons on the cloud service models, and here we're going to cover IaaS, Infrastructure as a Service.
This video is brought to you by EpiPies Academy.
This is how the NIST define it. So the capability provided to the consumer is to provision processing, storage, networks, and other fundamental computing resources where the consumer is able to deploy and run arbitrary software, which can include operating systems and applications. The consumer does not manage or control the underlying cloud infrastructure, but has control over operating systems, storage, and deployed applications, and possibly limited control of select networking components, for example, host firewalls. So with IaaS, this is the service model that gives the customer the most control. They get access down at the operating system level. But let's have a look at that by looking at the data center stack. So this is a reminder from the last lesson. With IaaS, the provider will manage from the facility up to the hypervisor, and the provider will also install the operating system and may patch it as well. The customer gets access from the operating system level, so they can customize the operating system as they want. They also install the applications they want on there and will be looking after their own data. So let's have a look and see how that works in AWS. So I've logged into the Amazon Web Services console and clicked on the Instances tab, and you can see the virtual machine that I created in the earlier lesson. I'm going to click on the Connect button and I'll get a pop-up. First thing that I need to do is to find out what the administrator password is, because this is the first time I'm connecting to this virtual machine. So I'll click on the Get Password button, and then I need to browse to the key pair that I downloaded earlier. So that was in my downloads folder. There's that demo.pem file. I'll double click on that. And now I can click on the Decrypt Password button, and it shows me the password that was created for the administrator account. So I'm going to copy that into my clipboard, and next thing I'm going to do is download the remote desktop file, which is going to make it easy for me to connect with RDP. I'll click on OK to download that into my downloads folder. I can close this, and then I will go to my downloads folder. There is the RDP file. I'll double click on that and click on Connect. And now I'm going to paste in the password that I copied and click on OK. And yes to the warning message. And then this should log me into the desktop of the virtual machine that I created. And there I can see my virtual machine is ready. I'm on the desktop now, so I'm in Windows. And what I would do now is I would install whichever applications I wanted to use this virtual machine for. Another thing that I would do at this point is also change the administrator password. There's a bit of a misconception where people think that if you're on infrastructure as a service, that the cloud provider also have access to your machines, so it's insecure. But that's not the case at all. It's best practice that the first thing you do is change the administrator password, and then it's only you that has got access to the desktop of your virtual machines. The provider does not have any access at all. So it is a secure solution. So you can see with infrastructure as a service, the provider is providing the underlying infrastructure and they installed the operating system for me. I get in at the operating system level at the desktop, and I can do anything I want with the virtual machine from there. Okay, let's go back to the slides again. And we'll have a look at the most well-known IaaS providers. You can see we've got Amazon Web Services up here in the top right. This is the Gartner IaaS Magic Quadrant that we're looking at now. Gartner are a research company, and they research who are the biggest players in cloud services amongst a whole heap of other things. AWS are by far the biggest cloud provider. They're actually currently bigger than all of their competitors combined. However, Microsoft Azure are gaining market share. They're able to do that because it can be a very cost-effective option for their customers, because pretty much all companies are Microsoft customers in some shape or form. They're probably using Windows as their desktop operating system. So because they're already a Microsoft customer, they can get cheaper options for using Microsoft for cloud as well. But AWS are still by far the biggest player with IaaS right now. If you have a look in the bottom section as well, you see Google also provide cloud services. Other well-known providers are VMware, have got their own service, also IBM Software and Rackspace. Okay, there's different flavors that are available for IaaS. Cloud providers will often offer 3 of these. The first is virtual machines on shared physical servers. We also have virtual machines on dedicated physical servers, and there's also dedicated bare metal physical servers. Now, if you're an IaaS customer, you don't have to choose one of the 3. You can mix and match between the 3 of them. Let's have a look at what those mean in a bit more detail. So the first one was virtual machines on shared physical servers. Here, different customers can have their virtual machines on the same shared underlying physical servers. So customer A could have a virtual machine on physical server 1, and customer B could also have a virtual machine on that same shared underlying physical server. This is the least expensive option because you're using shared resources. So it's most cost effective for the provider. They can pass those cost savings on to you as well as the customer. Typically, it's going to have the least amount of options in terms of how many vCPUs, RAM, and storage settings are available for the virtual machine out of the 3 possible flavors. The virtual machines can usually be provisioned more quickly than the dedicated options. These can usually be provisioned very quickly, typically in less than 15 minutes. And because it's the least expensive option, this is also the most commonly deployed option of the 3 as well. Next option we have is virtual machines on dedicated physical servers. Here, the customer is guaranteed that the underlying physical server is dedicated to them. So if customer A have got a virtual machine on physical host 1, no other customers are going to have any virtual machines on that physical host 1. The physical host is dedicated to them. This is a substantially more expensive option than virtual machines on shared physical servers. Because the provider has to dedicate physical hardware to that customer, it's going to be a more expensive option. There's typically more options here in terms of how many vCPUs, RAM, and storage options are available for that virtual machine. And because the customer has got dedicated hardware for them, they may be required to sign a minimum length contract for this, but not necessarily. It depends on the particular cloud provider. The last of the 3 options is dedicated bare metal servers. With these, a customer is given access to their own physical server down at the lower server level. I'll explain what that means a bit more in the next slide. A hypervisor is not installed and managed by the cloud provider. The customer can either install an operating system directly on the server, or they can install and manage their own hypervisor. This is the most expensive option of the 3, and it typically has the most options in terms of virtual CPUs, RAM, and storage options that are available. Again, the customer may be required to sign a minimum length contract. And AWS, or the biggest cloud IaaS provider, do not offer this option. With AWS, you only get the first 2 options currently. You can't get a dedicated bare metal server with them. So looking at the data center stack, where the customer gets in at is different if they're using dedicated bare metal servers. Let's quickly have a look back at how it works with virtual machines. So with virtual machines, the provider is going to look after everything up to the operating system level. Then the customer gets in at the operating system level at the desktop, and they can do whatever they want up from there. That is how it works with the first two IaaS flavors, the virtual machines on shared physical servers or virtual machines on dedicated physical servers. With dedicated bare metal servers though, it's different. The provider is going to manage the facility up to the compute level, but the customer gets in at the compute level. So they get in below the level of the operating system. The operating system is actually not even installed yet. So the customer will get access using some kind of management application like IPMI or Lights Out down to the physical server, and they're able to install the operating system from there. So they can install any operating system they want. They could install Windows on there, they could install Linux directly onto the hardware, or they could install their own hypervisor like VMware or Citrix XenServer. The choice of the operating system is up to them. So hypervisor is optional. Maybe they have a hypervisor, or maybe the OS is installed directly on the hardware. If the customer wanted to run just one workload on that particular physical server, like let's say they're going to run an Oracle database on there, they want to have a high performance server and the Oracle database is going to be the only thing running on the server. In that case, they would install the operating system directly onto the hardware. They wouldn't put a hypervisor in there because it's another layer, it's another thing that can go wrong, and it would add overhead as well. They're going to want the best performance for that particular workload. They would install it directly on the hardware. If, however, they wanted to run multiple workloads on that physical server, then they would install a hypervisor on it and they would run their workloads as separate virtual machines. Moving on, the most common reason to choose virtual machines on dedicated physical servers is for compliance. The customer may have some kind of regulatory requirement that means that they can't have virtual machines on shared physical servers. Dedicated bare metal servers will also fulfill the same compliance requirements. Both of these options require dedicated physical servers for the customer, so the cost is typically similar, with bare metal servers maybe being a little more expensive. A reason a customer may prefer virtual machines on dedicated physical servers out of these two options is if they do not have expertise in-house to manage the hypervisor. Looking back again, you see with dedicated bare metal servers, if they're going to be running a hypervisor on there, then they need to install it and manage it themselves. So they're going to need their own staff who have got expertise in that area. If, however, they go with virtual machines on dedicated servers, then the provider is going to install and manage the hypervisor for them. They just choose the operating system they want when they spin up the virtual machine, and they get in at that level. So that's the better option if they don't have IT staff who have got expertise in server virtualization. Moving on again, just like the customer may be offered options for shared or dedicated servers, they can also be offered options for shared or dedicated network infrastructure appliances like the firewalls and the load balancers. Again, it depends on the particular cloud provider if they're going to offer those options or not. Customers can typically connect into the cloud provider's data center over the internet and or via a direct network connection. With the storage options, customers will typically have the option of local hard drives in the server or external SAN or NAS storage. The customer also will often have the option of managing their own storage operating system on a virtual machine or bare metal server. With IaaS, the customer gets in at the operating system level, so they could install some storage management software in the operating system and look after their own storage. The most common reason for doing this would be if they want to look after their own encryption. The customer may also be able to install their own whole physical storage system in the cloud provider's data center. So maybe they've got a storage system from a company like NetApp or EMC. Maybe they can actually install that in the data center and connect their servers into that. Again, like everything here, it depends on the individual cloud provider. The customer can manage their servers to install applications and patches, etc. through standard remote management methods such as remote desktop for Windows servers and secure shell for Linux. You saw that earlier in this lesson when I gave you the demo. An API is also typically available to allow for automation of common tasks such as provisioning a new virtual machine. The customer may also have the option of applications such as Microsoft SQL or antivirus. They can either install the application and look after the licensing themselves, which would be a capital expenditure, or they can have the cloud provider do it for them, which would be an operational expenditure. So what I'm talking about here is, you know that the customer get in at the operating system level. So let's say that they want to run SQL Server on their virtual machine. They could install SQL Server themselves, in which case they would have to provide the license. Or if the provider provides this option, the provider can install SQL for them, and then the customer just pays for the license as a monthly fee to the service provider rather than providing the license themselves. The cloud provider may also offer to manage the application as well. They might have, in our example, SQL database admins on the provider staff who can look after the database for the customer. Okay, let's have a look at how the billing works with IaaS. For virtual machines on shared physical servers, the CPU and RAM will typically only be billed when the virtual machine is powered on. The physical CPU and RAM in the underlying server hardware will be available for use by other customers when the virtual machine is powered off, so the provider isn't going to charge you as the customer for CPU and RAM usage when you're not using it because you've powered the server off, so you can get some cost savings there. Network bandwidth will be billed as it's used. Some usage will typically be bundled in if you've got a monthly plan. Data storage will typically be billed whether the virtual machine is powered on or off, as the data is always going to be there and taking up physical storage space. Optional software extras such as a Windows operating system or SQL Server will be billed as a flat monthly fee. If you've got Linux in your virtual machine, well, Linux is a free operating system, so there's no additional charge for that. But if you want to be running Windows in your virtual machine, then there's a fee for that operating system, so the service provider will include it in the charge. Okay, let's have a look at some examples of billing. We'll have a look at AWS first. So I'm here on the AWS Simple Monthly Calculator, which is a tool that you can use to estimate what your monthly charge is going to be every month. First thing we do is up at the top, we choose the region because there's slightly different charges for different regions. I will choose Singapore in here. And then under there, you add your virtual machines that are on shared servers. So I'll click on the plus button and then select the type. So let's say that we have got a virtual machine which has got 4 vCPU cores and 16 gig of memory. That's the type T2 extra large in Amazon. So I'll select that and close and save. And you can see that the monthly fee for this server, if I had it powered on 100% of the time, would be a little over $175. You can also select your other options in here as well. For example, let's say that for that server, I also required 500 gigabytes of SSD storage. I can input that. And you see up at the top here, estimated the monthly bill $175. When I enter my additional storage, that cost will be added as well. That was about another $50 per month. Further down, you can add all of the other options as well. So that's how you can figure out your bill on AWS. Let's look at another example. We'll have a look at Telstra's pricing structure. So I've opened up their pricing guide, which comes as a PDF. Telstra are the main telco in Australia, and they also offer IaaS services. Telstra offer both virtual servers and dedicated servers as well. Let's have a look at how the billing works for virtual servers on shared underlying infrastructure. You can see that Telstra use a monthly plan structure. So if you spend $200 a month with them, you get the extra small plan where you get 2 vCPUs and 4 gig of RAM. If you go up to $4,000 per month, you get 64 CPUs and 256 gig of RAM. Now these vCPUs and RAM, that can be divided up amongst multiple different virtual machines. So you could, for example, have 8 virtual machines with 8 cores each, or you could have 16 virtual machines with 4 cores each, or however you want to mix and match. They also have a pay-as-you-go plan as well, but you get a bit of a discount if you go onto one of the monthly plans.